Have you ever pondered about the ultimate destiny of our universe? Imagine a future where entropy reigns supreme and usable energy ceases to exist. Today, we're exploring the intriguing concept of the universe's heat death. So let's dive into the fascinating theories of the universe's heat death. The heat death of the universe is a theory about the ultimate fate of the universe. This theory paints a picture of a universe far, far into the future, a universe that has expanded to such a degree that it has essentially worn itself out. The driving force behind this chilling scenario is a principle you may have heard of: entropy. In layman's terms, entropy is a measure of disorder or randomness. The second law of thermodynamics states that in any closed system, like our universe, entropy will always increase over time. Now imagine every star in the sky, each a powerhouse of energy. Over unimaginable stretches of time, these stars will exhaust their nuclear fuel. As they burn out and fade, the universe will slowly cool, a process known as cooling flow. This isn't something that will happen overnight or even in a billion years. We're talking about a timescale so vast it's almost beyond comprehension. In this distant future, galaxies will drift apart, stars will die out, and all usable energy will gradually diminish. Eventually, the universe will reach a state of maximum entropy, where all matter and energy are evenly distributed. This is the heat death scenario, a universe devoid of structure, of life, of change. Now let's explore the top 10 theories related to this concept. Our first theory revolves around the second law of thermodynamics and the concept of entropy. Now, the second law of thermodynamics is a fundamental principle of nature. It states that the total entropy, or disorder, of an isolated system can never decrease over time. It can only increase. Picture a room with a single air freshener. At first, the scent is concentrated in one spot, but over time it spreads out evenly. That's entropy in action. Now let's apply this to the universe. In its youth, the cosmos was a hot, dense point of singularity. As it expanded, energy and matter spread out, increasing entropy. Fast forward billions of years, the stars burn out, galaxies drift apart, and the universe becomes a homogeneous soup of particles. Energy gets spread so thin that no new stars can form, no life can exist. As entropy increases, the universe moves closer to its inevitable heat death. The second theory brings in the mysterious dark energy and predicts a big freeze. Dark energy, the unseen force that makes up nearly 70% of the universe, is a key player in this theory. It's a strange concept, but dark energy is thought to be the driving force behind the accelerating expansion of the universe. Imagine a balloon being filled with air, expanding outward in all directions. This is what's happening to the universe, but on an unimaginably large scale. And just like the balloon, as it expands, the universe cools down. This is where the big freeze comes in. As the universe expands, galaxies drift apart, becoming isolated in a sea of increasing darkness. Star formation slows, the lights begin to go out, and eventually the universe reaches a state of maximum entropy. This is the point at which no usable energy remains. The universe, once a bustling hub of energy and matter, becomes a cold, dark, and lifeless expanse. Stars burn out, galaxies fade away, and all that remains is a vast cosmic graveyard. But remember, this is just a theory, one of many that attempt to predict the fate of our universe. The big freeze is a chilling thought, isn't it? A universe slowly dying, fading away into the darkness. But don't worry, it's not all doom and gloom. Other theories suggest different, less bleak outcomes. This theory suggests that the universe will end not with a bang, but with a whimper. Our third theory involves the enigmatic black holes and Hawking radiation. Now, black holes are known to be these mysterious, voracious cosmic entities, swallowing everything that comes too close. But according to Stephen Hawking, black holes are not just cosmic sinks. They emit radiation too, a phenomenon we now call Hawking radiation. Imagine a pair of particles popping into existence right at the edge of a black hole, a common occurrence in quantum mechanics. One falls in, the other escapes. The energy for the creation of these particles comes from the black hole itself, gradually reducing its mass over incredibly long periods of time. This is a process known as black hole evaporation. So how does this relate to the heat death of the universe? As black holes continue to evaporate, they release Hawking radiation, which is just thermal energy. This energy contributes to the overall entropy, or disorder, of the universe. In a universe far in the future, where stars have long burnt out and galaxies have drifted apart, these slowly evaporating black holes could be the last significant sources of energy. But even they won't last forever. Eventually, after an almost unimaginable stretch of time, the last black hole will evaporate, leaving behind nothing but a soup of particles and low-energy radiation. With the evaporation of black holes, the universe could be left in a state of high entropy. The next 4 theories take us deeper into the realm of theoretical physics. First up, we have string theory. This theory suggests that the fundamental particles we observe are not zero-dimensional points, but one-dimensional strings. In the context of the universe's end, string theory offers a possibility that's not as bleak as the heat death. It suggests that the universe might undergo a cyclic process of expansion and contraction known as the Big Bounce, avoiding a final state of maximum entropy. Next on our list is the multiverse theory. It proposes that our universe might just be one of many, perhaps an infinite number, within a vast multiverse. Each universe in this multiverse could have different laws of physics, different beginnings, and different ends. If our universe is headed towards a heat death, another might be in the throes of a big crunch, while yet another might be just beginning. The multiverse theory paints a picture of endless variety and change, rather than universal stagnation. Third in line is quantum theory. Quantum mechanics is a branch of physics that deals with phenomena on a very small scale, like atoms and subatomic particles. One of its most intriguing aspects is the concept of quantum fluctuations, temporary changes in energy that allow for seemingly impossible things to occur. In relation to the heat death, quantum theory suggests that even in a universe with maximum entropy, quantum fluctuations could potentially give rise to a new Big Bang, creating a new universe out of the ashes of the old. Lastly, we have the Big Rip theory. This theory is based on the presence of dark energy in our universe. If the density of dark energy increases over time, it could become so powerful that it tears apart everything in the universe, from galaxies and stars to atoms and subatomic particles. The Big Rip represents an alternative to the heat death, where the universe doesn't slowly fade away, but is violently torn apart. These theories offer diverse and mind-bending possibilities for the universe's end. Our final 3 theories propose even more astonishing endings for the universe. Let's begin with vacuum decay. This theory suggests that there is a lower energy state out there than the vacuum of space we currently inhabit. Picture this: a tiny bubble appearing in the universe filled with this lower energy state. This bubble would then expand at the speed of light, obliterating everything in its path. The laws of physics would change within this bubble, making the existence of matter as we know it impossible. It's an abrupt and complete end, not just for us but for the entire universe. Next, we have proton decay. This theory is based on the idea that protons, one of the fundamental particles in atoms, are not actually eternal. They might have a finite lifetime and could spontaneously decay into smaller particles. Now, if this is true, then over an unimaginably long time scale, all matter in the universe would slowly decay away, leaving behind a sparse soup of photons and leptons. Unlike the sudden end of vacuum decay, proton decay predicts a slow, gradual fade out of the universe. Finally, let's explore the Big Bounce theory. This one's a bit more optimistic. The Big Bounce proposes that our universe is just one phase in an infinite cycle of expansion and contraction. So, after the universe has expanded to its maximum extent, it'll start to contract. All matter, energy, space, and time will collapse into a singularity, similar to what's found at the center of a black hole. But instead of a dead end, this singularity will then explode in another Big Bang, giving birth to a new universe. So the death of our universe might just be the birth of the next. Each of these theories present a different relationship with the concept of the heat death of the universe. Vacuum decay could occur at any time, irrespective of the universe's heat death. Proton decay, on the other hand, would contribute to the heat death, as the decay of all matter would leave the universe in a state of maximum entropy. The Big Bounce, however, provides an escape from the heat death. If the universe contracts and bounces back, it would reset the cosmic clock, starting a new cycle of low entropy. It's fascinating to think about, isn't it? Our universe could meet its end in an instant with the appearance of a lower energy state bubble, or it could slowly fade away as all matter decays. Or perhaps our universe is just one of many in an eternal cycle of death and rebirth. These theories suggest that the universe's end could be both catastrophic and spectacular. The ultimate fate of the universe is still an open question, but one thing is certain: the cosmos has a few tricks up its sleeve, and its final act is sure to be a showstopper. So, what does the future hold for our universe? The universe, in all its vastness and complexity, is a hotbed of theories about its ultimate fate, each more fascinating than the last. We've delved into 10 of these theories, each offering a unique perspective on the grand finale of the cosmos. Beginning with the laws of thermodynamics and entropy, we learned that all systems tend towards disorder. This suggests a future where the universe reaches maximum entropy, a state of complete uniformity where no work can be done, a scenario often referred to as the heat death. Subsequently, we explored the impact of dark energy and the Big Freeze. This theory proposes that the universe will continue expanding, cooling as it does so until all star formation ceases and existing stars fade out. Next, we ventured into the realm of black holes and Hawking radiation. If black holes evaporate over time, releasing energy in the form of Hawking radiation, the universe could eventually be left with nothing but a diffuse cloud of particles and low-energy radiation. Our journey then took us through the intricate realms of string theory, multiverse, quantum theory, and the Big Rip. These theories explored the possibility of multiple universes, the fundamental nature of matter, and the idea that the universe could tear itself apart due to the accelerating forces of dark energy. Finally, we questioned the stability of our universe itself in the theories of vacuum decay, proton decay, and the Big Bounce. These theories suggest that a phase transition could occur, causing the universe to collapse and possibly rebound, creating a new universe in a cycle of cosmic rebirth. Each of these theories presents a different vision of the universe's future, from a silent, frozen expanse to a universe torn apart, or one that cyclically recreates itself. Each is grounded in our current understanding of physics and cosmology, but each also pushes the boundaries of our knowledge, inviting us to question, explore, and imagine. While we may never know for sure, exploring these theories gives us a glimpse into the fascinating possibilities for the ultimate fate of our universe. Thank you for joining us on this fascinating journey through the universe's possible fates. Did you learn something new today? If so, give this video a like. We'd love to hear your thoughts and opinions on these theories. Do you have a favorite? Or perhaps you have your own theory about the end of the universe. Share your thoughts in the comments section below. We'd love to know what you think. If you want to keep exploring the cosmos with us, be sure to hit that subscribe button and press the bell icon. That way, you'll never miss out on our latest content. And if you think your friends or family would enjoy this journey through the cosmos, don't hesitate to share this video with them. Let's continue to question, explore, and imagine together. Until next time, keep looking up.